Welcome back to another video, and in this video we're going to be relating back to something that we've learned before, which is derivatives. Now, when we solve for the derivative of a function at like a certain point, that's just basically finding the slope of a certain point, right? But how can we do that with implicit differentiation instead, right? So in the previous video, since we talked about implicit differentiation, we basically have to take the derivative of everything with respect to whatever variable there is, and then we had to isolate like dy over dx or any other variable, any other operator that we need to find. So let's take an example of x squared plus y squared equals 25, and we want to find the slope of the tangent line at the point 3 comma 4, right? So how do we necessarily do this, right? Now, in this case, we would first have to find the implicit differentiation, which is dy over dx in this case, and then we would have to solve it so that we can get the slope of the tangent line. So let's first take the implicit differentiation of this specific function. It'll be 2x dx over dx plus 2y dy over dx equals to 0, right? And dx over dx is just equal to 1. So then it's just going to be 2x plus 2y dy over dx equals 0. You subtract the 2x on both sides. You get 2y dy over dx is equal to negative 2x. And of course, lastly, we isolate the dy over dx, which is negative 2x over positive 2y, right? So now this is our little equation so that we can use to find the slope of the tangent line, right? Now, since we have the points here, 3 comma 4, we can plug those into our dy over dx. So dy over dx is just equal to negative 2 times the x value, which is 3 in this case, over 2 times the y value, which is 4 in this case. And this will give us dy over dx is equal to negative 3 over 4, because the 2's cancel out, so we get negative 3 over 4. Now, since we just found what our what the slope of the tangent line is equal to, right? How can we find what is the equation of the tangent line, right? So in this case, just because we want to find the equation of the tangent line, and we already know the slope of the tangent line, which is just negative 3 over 4, we can use point slope form, right? In the past, we've also used point slope form for derivatives, finding the derivative at a point, and then finding the equation for it, right? It works the same exact way. So now the point slope form is just y minus y1 equals to m times x minus x1, right? So we're going to put this on a new slide here. And point slope form. And how would we actually find how we're going to do this, right? So we have our coordinate as the coordinate of our point is just 3 comma 4, right? And we know that our dy over dx is just equal to negative 3 over 4, right? This is what we call our slope. So now, of course, our y value is 4, and our x value is just 3, right? So in this case, just to make up the formula or the equation for it, y minus 4 is equal to negative 3 over 4 times x minus 3. And that is how we get our equation of a certain point on our original equation of x squared plus y squared equals 25, and we just took the derivative of it. So that's basically just the whole entire point of how we're going to do this. So now let's take another example here. So as our other example, we want to find the slope of the graph of y plus 2xy minus x squared equals 11 at the point 3, 2. Now take a moment here and pause the video and see if you can figure this out. Remember, this is only asking for the slope of the graph. It's not asking for the equation. It's only asking for the slope. Alright, so hopefully you just took a minute and looked at this question and see if you can try to figure this out, right? So our first step here is to find the derivative of this whole entire function. We're going to use implicit differentiation now. So now let's do this. The derivative of y is just going to be dy over dx, right? dy over dx plus 2xy. Now remember, in this case, right, we're gonna have to use the product rule, right? With this, you have both the x and you both have the y, right? So if we say that our function, since 2 is a constant here, right, so we can put it on the outside, and x times y, the derivative of x times y is just going to be using the product rule, which is f prime of x times g of x plus g prime of x times f of x, right? So the derivative of x is just dx over dx, which is just 1. And then we have g of x, which is just y, right? And then you add g prime of x, right? So the derivative of y is just dy over dx. So we're going to write dy over dx here. And then you have our x here, so times this by x. And then now for this last term here, negative x squared, we can just write it as the derivative of x squared equals 2x, so that means minus 2x equals, and the derivative of a constant is just 0, right? So why don't we first like distribute the 2 so that we can have actual terms instead of like having terms multiplied with parentheses here. So dy over dx plus 2y plus 2x dy over dx minus 2x equals 0, right? So now in this case, right, what can we do next? So we want to isolate dy over dx. So we're going to move any term that does not have dy over dx onto the other side. So we're going to minus the 2y here, and then we're going to plus the 2x. So then it becomes dy over dx plus 2x dy over dx equals to 2x minus 2y, right? And now what we want to do is basically factor it so that we can basically get rid of whatever is outside of the dy over dx. Now the common factor here is the dy over dx, so we're going to put it on the outside. Dy over dx, parentheses, we have the 2x here, and then we have an imaginable 1 here, so 2x plus 1 equals 2x minus 2y. And then in this case, just to solve for dy over dx, we have to divide whatever is inside of the parentheses on both sides, and that'll be equal to 2x minus 2y over 2x plus 1. So this is what our derivative equation is, right? So now how can we actually use this to find out what our slope is, right? So we're gonna use the points 3, 2 from up here, right? These points. And we're gonna plug them into whatever we just got for our slope of the graph, right? So our coordinate is 3, 2. We're gonna write it here. Chord is 3, 2. And we're gonna plug this in. So dy over dx is equal to 2 times the x value, which is 3, minus 2 times the y value, which is also 2, over 2 times the x value, which is 3, plus the 1 at the end. So now dy over dx is equal to, let's see, we have 6 here, we have 4 here, and then we got another 6 here. So that would be 2 over 7. So our slope of this line is 2 over 7. Now, what if I asked you to now find the slope of the tangent line? I mean, find the whole entire tangent line equation, right? So, see if you can find the equation of the tangent line with the information provided here. Hopefully you just took a moment and tried to find the equation of the tangent line here. It is truly really simple. So since we know that this is our slope and then our coordinates are up here, right, we're going to use the point slope formula. So the point slope formula says y minus y1 equals m times x minus x1. Now since our y value is 2, it'll become y minus 2, and then that's going to be equal to the slope, which is 2 over 7, times x minus our x value, which is 3. And that is how we find our whole entire equation of the tangent line. So as a major takeaway, in this video we just figured out how to find the slope of the tangent line for implicit differentiation cases, and also at the same time we also found the equation of the tangent line of implicit differentiation cases. So now remember to, whenever you're doing implicit differentiation, remember to put all of the dx over dx or just the dy over dx in general. For example, we have here, right? And also remember that we want to isolate it so that we can have dy over dx. So make sure you guys keep on practicing this, because this is a topic that most people don't understand and they don't really get it. So if you do more practice, you're gonna get it more. And I will see you guys in the next video.